Hello, this is a instructional math video for Math 152 IN1 at Haywood Community College. This instructional video is to show an example of the use of normal distribution. This is problem number 25 from page 263 out of our text. It is dealing with a water taxi that sank in the Baltimore Harbor. And it revealed that the safe passenger load for the water taxi was stated at 3,500 pounds. It was also stated that the mean weight of a passenger was assumed to be 140 pounds. Assume worst case scenario in which all passengers are adult men, so we're assuming men would weigh more than women or children. Assume that weights of men are normally distributed with a mean of 182 pounds, which I've labeled here with mu, and a standard deviation of 40.8 pounds. And those numbers actually come from an appendix in the book, which is from actual data of a random sample of men. So the validity of that data should be pretty good. So if one man is randomly selected from the population, find the probability that he weighs less than 174 pounds, which is the new value of the weight of an average man suggested by the National Transportation and Safety Board. Okay, so we've got our mu, we've got our sigma. Since our data is normally distributed, we can use the rules of normal distribution. Our mean in this case is not 0, and our standard deviation is definitely not 1. Therefore, we need to use z-score to standardize our data. So we've got our z-score. Z equals x minus mu divided by standard deviation. So let's first find the z-score for 174 pounds, and the z-score essentially describes how many standard deviations away from the mean we are. So 174 minus mean of 182.9 over standard deviation 40.8. Okay, so calculate that. 174 minus 182.9 is negative 8.9 divided by 40.8 is negative 0.21813. Okay. Our z-score is negative in this case because our data point of 174 is less than the mean. So data that is less than the mean is going to give us a negative z-score. Data that's greater than the mean is going to give us a positive z-score. So if we look at what's happening graphically, okay, we've got our bell curve. Since this is a normal distribution, okay, we've got our mean in the middle, 182.9, and then our data point, 174, is to the left of the mean. Okay, and we want to find the probability, or the area under the curve, that a randomly selected person weighs less than 174. So we're looking the area under the curve, or the probability that's to the left of 174. So we want to essentially find the area of this shaded region. Okay. So our z-score and our z-table helps us do that. Okay, so since we have a negative z-score, we want to utilize the negative z-score table. Okay. And what this z-score table does is it gives us z-score values on the outside of the table, and then it gives us areas under the curve, which are probabilities in the middle. That's associated with those z-scores. Okay. Notice to the left, you've got the whole number of the z-score and the tenths place, and then up here you've got the hundredths place of the z-score. So you've got to match that up. Okay, so we wanted a z-score of negative 0.21813. Okay, so since we're dealing with hundredths place here, I'm going to round this to negative 0.22. Okay. So if we look at our z-table, okay, look on the left-hand column, we find negative 0.2. Okay. And then we want to find 0.02, which would be the hundredths place, to give us negative 0.22. So you've got the tens place and the whole numbers on the left-hand column, and the hundredths place up here on top. Basically match those up. So go down the hundredths place column over until I match up with the row of the tens place, and that gives me the probability or area under that curve. So 0.4129. So that is our area underneath the curve, which is also our probability. Okay, so there is a roughly 41.29% chance that if we randomly selected a adult male from the population, that they would weigh less than 174 pounds. So less than a 50% chance. Okay, so if we look at the next question here, it asks us if one man is randomly selected, find the probability that he weighs more than 174 pounds. Once again, we need to use our z-score, right, because our data is not standardized. So we need to standardize it by, once again, using our z-score. Our z-score is not going to actually change, because we're using the same number of 174. So that's still going to give us a z-score of negative 0.21813. So that's not going to change. But when we look at this graphically, we're looking at a different part of the graph. Okay, we still have our mean of 182.9. We have our data point of 174, but instead of looking at less than 174, we want to look at more than 174, so we're looking at data to the right of that point. Okay. So we already figured out from the previous problem that the area to the left of 174 was 0.4129. Okay. So then if we take into account that the area under the entire curve represents all possible probabilities, then the area under the entire curve is equal to 1. So then if we take away this part, which is to the left of 174, which we found in the previous problem, then we're left with what's to the right of 174. Okay, which would be .5871. Okay, so then this area underneath the curve to the right, 0.5871. Of course, when we add this number and this number together, that's the entire curve, which would be equal to 1. Okay. So what that essentially tells us in the problem, and of course this would be a 58.71% chance, right? Going back to the water taxi, is that there's no way this 140-pound estimate for the mean weight of a passenger could be accurate. That may have been the mean weight of a passenger years ago, but with lots of different reasonings for why the weight of individuals have increased, that's no longer valid, right? Adult men, are weighing more than 140 pounds. So that gives reason that this value needs to change, right? Which would then change how many people could be safely floated on the taxi without having it sunk. Okay. So that gives us a lot of good information there, okay, in terms of the safety of the boat. Okay. It also tells us that even the 174-pound estimate, which is the new value suggested for the National Transportation Safety Board, should also be re-examined. That value should probably be increased as well, based on the mean and standard deviation that we're using of our data. Okay. So that gives us some information in terms of the problem. Finally, C asks, if one man is randomly selected, find the probability that he weighs between 175 pounds and 185 pounds. So let's examine this graphically so that we can get a game plan for solving this particular problem. We've got our mean of 182.9 in the middle of our curve, 185.9, or 185, excuse me, and 175. And we essentially want to find between those two. So we want to find this part of the curve. Okay. So if we think about this graphically, right, if I take the entire area that's to the left of 185, okay, and I subtract out the area that's to the left of 175, right, that is going to give me the middle between those two numbers, right? So that's going to be our process for finding this solution of the in-between values, or probability. Okay. So let's first find the probability that it's less than 185. So once again, we need to use a z-score. Okay, so this z-score should be positive because it is above the mean. And it is. Okay. So then we would want to use our positive z-score table in this case and find 0.05. So if we look here at the top, we've got 0.0, and then here's the hundredths place of 5, so 0.05. And that's 0.5199. So that's the area underneath the curve to the left of 185. Okay. So then we want to find the area to the left of 175. Once again, we need to find the z-score. This one should be negative. Okay. So we get negative 0.1936 as the z-score. So we looked that up on the negative z-score table. So we would be looking at negative 0.19 So if we look at negative 0.1, and then we've got 9 in the hundredths place here. So look at where those match. We're looking at this number here, 0.4247. Okay. Okay. Alright, so now we want to subtract those probabilities to find the value in between. So 0.5199 minus 0.4247, so 0.0952, so roughly 9.52%. Okay. So, and of course this percentage is smaller because we have a smaller interval that we're looking under. We're only looking at a 10-pound interval from 175 to 185. Okay. However, there's almost a 10% chance that we're going to find a person between those two numbers. So, that gives a little bit of evidence, I guess, that the 182.9, truly is fairly close to the mean of the adult male population. Okay. But the main purpose of the video is to show you how to do normal distribution, both with finding the probability less than a certain amount, such as A, greater than a certain amount in B, and then in between two amounts in C. Okay. The z-tables, both positive and negative, are on Moodle, so you would definitely want to print those out. There are other examples in the notes in Moodle that should help you. I will actually post this to Moodle as well, so that you have a copy of it. And then hopefully the video helps, gives you an explanation of how to find these probabilities. If you have any questions, please email me or stop by office hours. If office hours don't work, then we can definitely find another time that works with your schedule to meet and go over some examples. Alright, thank you very much.